Myself, Dr. Sushma Jain, Associate Professor Chemistry, Government Dungar College, Bikaner. Today, I shall discuss about the orientation in a fused aromatic ring and heterocyclic compounds. In fused aromatic rings, the positions are not equivalent. There is usually a preferred orientation. In case of naphthalene, the preferred orientation is alpha rather than beta, because on seeing these resonating structures, 5 resonating structures obtained by alpha take of naphthalene, in these resonating structure, these two structures are more stable because the aromatic sextet in one ring is preserved. In these 3 structures, the aromatic sextet disturbed in both the rings, also in both the rings. Therefore, these 3 structures are unstable structure, and these 2 structures are more stable structure in case of alpha attack. But in case of beta attack, only the one structure has one ring A complete aromatic sextet. Therefore, this structure is more stable than the other resonating structures where the both ring has disturbed and the aromatic sextet is disturbed in the both ring. Therefore, this structure is only one structure is stable structure in case of beta attack. Here 2 structure is more stable. Therefore, the alpha attack is preferred in case of naphthalene. The rate of reaction in case of naphthalene is more than the benzene, or we can say the reactivity is greater than the benzene and the other fused ring systems such as anthracene, phenanthrene. Also, the rate of reaction is greater than benzene. Now, when fused ring system contains substituent, here we take substituent CH3, and this is the resonating structures on electrophilic aromatic substituent. The Y is the electrophile. Here, when at position 1 electrophilic substitution takes place, 2 possible resonating structures is found where in one ring the aromatic sextet is preserved, in one ring the aromatic sextet is preserved, and more resonating structures are also found, but where the both ring the aromatic sextet is disturbed in the both ring. So we take into account only these 2 structure which is more stable structure than the other structures, and when the substitution takes place at position 1. But when we take the substitution at position 3, here the resonating structure obtained this and so on. But here only one resonating structures in which the ring A has complete sextet of the electron, aromatic sextet, complete octet of the electron, or we can the aromatic sextet is preserved in the A ring. Here aromatic sextet is disturbed. So only one structure is in case of attack at position 3, and here 2 structure in case of the attack at position 1. Therefore, the preferred orientation is the electrophilic aromatic substitution takes place in this compound at position 1, and the rate of reaction is greater than the benzene. In case of heterocyclic compound, we take the case of 5-membered ring such as pyrrole, thiophene, fural. Z is the heteroatom. It may be nitrogen, it may be oxygen, it may be sulfur. When heteroatom here and 5-membered ring takes place, then attack position may be 2, 3 or 2 and 3. In case of position 2 attack, 3 resonating structures is obtained, in which structure Third is more stable because the octet is present in all the atoms. Here only at attack at position 3, 2 structure is obtained. Therefore, the more the resonating structure, more will be the stability of the intermediate cation, and therefore the preferred orientation is position 2. The 5-membered ring takes substituted at position 2, and the reactivity is greater than the benzene. But in case of 6-membered ring, the attack can be takes place at 2, 3 and 4. But in case of at attack 2, one structure is obtained which is unstable structure because the electronegative nitrogen has positive charge and only sextet of the electron is present at this nitrogen atom. In case of attack at position 4, also this type of the structure is obtained. Here this is the less stable structure, therefore the only 2 structures give their contribution in the stability, and here also these 2 structures give their contribution in the stability. But in case of attack at position 3, 3 structures obtained, no such unstable structure is formed. Therefore these 3 structures give their contribution for the stability of the intermediate cation. Therefore the preferred orientation in case of pyridine is position 3. Now in other fused rings heterocyclic compound, we can often make prediction based on the above principles, though many exceptions are known, such as in case of indole, the reactivity is greater than benzene and the electrophilic attack takes place at the pyrrole ring and at the position 3. And in case of quinoline, the reactivity is lesser than the benzene and the electrophilic aromatic substitution is takes place in the benzene ring rather than pyridine ring and takes place at the position 5 and 8 position. Therefore, in this way we can explain all the examples.